Okay, let's pick up here at 27. We did 23 through 26 in another video. So 27 it is. If CF is 5, so what's CF? CF is once again this outside segment, right? It's a tangent. That's a tangent segment is 5. And FK, where's FK? FK goes this way, right? Down towards H probably. FK is 2. Then what is K to H? Okay, so hopefully you're looking at this. Let me redraw it maybe for you. Here we go. CF is your tangent, and then this is your secant. So once again, this is going to be a secant tangent problem. Secant tan. So the secant tangent goes the inside plus the outside. So x plus 2 times 2 equals 5 squared. Okay, so we do some algebra. 25 minus 4. Divide that by 2, right? So we're going to distribute into here. 2x plus 4 equals 25, and x equals 10.5. So in this case, KH, which is your x, is 10.5. Okay, BC is 100. Where's BC? Arc BC. There it is. BC is 100. Then the measure of angle CAB. CAB is down here, okay? So that means CAB is an central angle. Okay, and a central angle is equal to the intercepted arc, so that means that CAB has to be 100 degrees. Okay, the next one says, well, BC is 100, but then what is CDB? Okay, so this is an inscribed angle. Okay, so we have a central angle which is equal to the arc, and then we have an inscribed angle which is half of the arc. So that means angle CDB is going to be 50 degrees. Okay, GH is 120. So where's GH? There's GH. G to H is 120. Believe it or not, it is. HB is 90, so this one over here is 90. GH is, oh, that says GC, doesn't it? Oh my goodness. This one up here is 120. So sorry. Okay. It's a good thing that we are reading these problems for real. This one is 20. GH is 20. Okay, there we go. Then what's the measure of angle E? Okay, so angle E is an exterior angle like we had in the previous video. Okay, so in order to find angle E, I need to know what is the arc of CB, right? Because this is your big arc, 20 is your little arc. So we can set up the equation x equals half of the big arc, which we don't know right now, minus the little arc, which is 20. So all of the arcs of a circle add up to 360. Okay, all the arcs of a circle add up to 360. So I do 360 minus 120, right? I know that one, minus another 20, minus 90, and I get that big arc to be 130 degrees. Okay, for this problem, arc CB is 130. So 130 minus 20, that's 110. Half of 110 is 55 degrees. So that's the answer for the measure of angle E, 55 degrees. Okay, let me erase and we'll start the next one. Okay, 31, EG. EG is 10. Okay, so that's a segment, right? EG is a segment. 10. GC is 20. So here's another segment. Okay, this is making us think that this is going to be a segment problem, not an angle problem. EH is 8. What is HB? So this is definitely going to be an angle problem. Okay, so this is going to be a secant angle or segment, not an angle problem, sorry, a segment problem. Secant segments. So we're going to use that secant segment formula, which says the inside plus the outside times the outside, right? So I'm doing 20, which is an inside part, plus the outside part of 10, equals the inside plus the outside, right? That's the entire length, times the outside for your bottom one. Okay, so knowing whether it's an angle problem or a secant problem, right? So there's no degrees on any of these. These are not angles. 20 plus 10 is 30. 30 times 10 is 300 equals 8x plus 64. Okay, so 300 minus 64 is 236. And dividing that by 8 gives us 29.5. So the length of HB, right, we're on 31. The length of HB is 29.5. Okay, so knowing whether it's an angle problem like it was up here, right, 30 was an angle problem because we had a whole bunch of angles. Then you have an angle problem at the end. Well, these are all segments, so we have a segment problem. Okay, let's see about 32. Let me erase. Well, I don't think I need to. Let's see. MB is 10, so M to B is 10, right? That's an inside segment. GM is 6, that's here, GM. MC is 5, that's here, 5. And we want to figure out what is LM. Okay, so these are inside segments, which is a chord. So we're going to use the chord theorem's relationship, which says we multiply down the chords. So x times 10 needs to equal 5 times 6. X times 10 equals 5 times 6. Okay, so 10x equals 30, which means x equals 3. So LM is going to be 3. Okay, hang on, let me refresh this and then we'll go back to 33. 33 says angle DB, so we're back to angles, right? This is an angle D to B. D to B is 110. Angle D, where's angle D? Angle D is 30. Okay, let's figure out where angle, looks like this is angle D maybe. 30 degrees. Arc CL is 60, right? This is an arc. Arc CL is 60. Why is my pen not working? Arc EL is 60, CL. Then what is D to L, right? That's our question. So let's see, where is D to L? D to L. Okay, I know this is 110. And let's point out what is LB. LB is a diameter. Right, a diameter splits your angles or your circle into 180 degree portions. Okay, well that's good to know. Actually, I'm not believing that right now. So let's do the math here. Angle D is 30, which means that C to B has got to be 60. So this, it looks like we don't have a diameter. Let's don't think about that. That's, oh, I should erase that. That is faulty assumption on this part. Okay, so 60, 110, 60. I'm just going to figure out what this is because all of these add up to 360. Right? All of your arcs add up to 360. So 360 minus 60 minus 60 minus 110 gives me a 130 degree arc for DL, 130. Okay, so CB is 90, okay, let me clean this up. Hang on one second. There we go. CB is 90, even though it doesn't look like it. We're saying it's 90, which means this is, of course, a 90 degree angle in there. Angle E is equal to arc GH. So these and these are equal. Okay, then what is the measure of angle E? Okay, so this is X and this is also X because they're equal. Right, one's an angle, one's an arc, that's okay. So we're going to use our outside angle again, or your exterior angle. So X equals half of the big arc, which in this case was 90, minus the little arc, which is X. Okay, so we're times by 2 to get rid of the 1/2, right? This is our classic algebra. 2x equals 90 minus X. Okay, we will add X to both sides now. So there's our algebra. 3x equals 90, and dividing by 3 means both your angle and your arc are 30 degrees. 30 degrees. And then lastly, let's see what's going on here. AB is 100. So where's AB? That's your radius. So we have a radius of 100. CAL is 90. CAL, where's CAL? So this is now a 90-degree angle. CAL is 90. Okay. Then what is the length of L to B to C? So this is an arc length problem. L to B to C. Okay, this is an arc length problem. So arc length, there is a proportion, right? The formula is the proportion. So arc length over circumference, 2 pi r equals the angle. So if we had a 90-degree angle, then all the rest of it is going to be 270, right? So this is 90 degrees, which means the angle that we want is 270. So we subtract it from 360 in order to do that. And now we cross multiply. So 270 times 200 times pi divided by 360 gives me an arc length of 471.239. Okay, so these are all the right answers. I know there was some questions about the key on your Schoology page, but these are all the correct answers. You saw me do all the math for them. So those are all of the circles, right? There's a bunch of formulas. Know whether they're talking about angles or talking about segments. Okay, and if you have a question on your test, simply raise your hand and ask me, and I'll tell you whether you are correct in your assumption of angles or segments.